All right, AP, let's get started with the Chapter 1 video lecture. Please remember that this is not designed to replace reading out of your book. Reading out of your book is absolutely fundamental, is foundational to your ability to perform on the AP exam when that time of the year comes. This is supplementary. This is supplementary. This is in addition to what you already do. So I will tell you, please watch these videos more than once. This is not the type of class where you want to show off how little you have to try. In fact, it's the opposite. You want to show off how much you can try. The entire goal of this course is to get you prepared to get a qualifying score on the AP exam, which will be taken in early May. And you have to be ready. There are no excuses for why you are not ready to go on that particular day. If you're sick, if you miss some days right before the test, if you didn't get a good night's sleep before the test, there are no excuses. You will not be given another chance to take that exam. So we want to make sure that we're ready. So let's get started with Chapter 1, Chemical Foundations. This stuff should sound fairly familiar, not only from Gen Chem, but from other courses, other science courses that you've taken. Let's start with chemistry as an overview. We're going to talk about matter. Yeah, it's going to be a large portion of this course, talking about what matter does and how to describe or measure that. Matter is anything that takes up space, has mass, and this is the thing that we're going to be measuring, by the way. The mass is what we'll measure. And if you took a year break between Gen Chem and AP Chem, you may have taken physics during that year, in which case you probably talked about inertia, which refers to Newton's laws of thermodynamics, and we will talk a little bit more about those when we get to that chapter. But we really focused on matter when we were in Gen Chem. Right? We really focused on matter. As we move forward, we're going to add to that, right? So we're not in Gen Chem anymore. We are in AP Chem. And so not only will we focus on matter, yes, we definitely will, but we're also going to be talking about energy. Right? We're going to be adding new terms, new skills, and the ability to describe matter. And it changes in matter especially. But let's take a quick overview of what matter is, right? All matter that we know of is composed of a little bit less than 100 atoms or so, different types of elements. Now, hopefully you guys remember that number 92, uranium, is the last naturally occurring element on the periodic table, and anything after that is going to be man-made, right? And it's going to have a very, very short half-life relatively. Uranium is the last thing that happens naturally. You would never be able to, for example, go out into the world and find a chunk of neptunium that was already there. It must be made. It must be made in a lab. But all matter that we know of, and I'm not referring to dark matter here, by the way. We're not going to deal with dark matter, dark energy, because next to nothing is known about those things. They're very, very difficult to study. That's why they're called dark matter, dark energy, because very little is known about them. But we're going to talk about the type of matter that we are aware of, that we can measure, that we can touch and manipulate. So all matter is made up of only about 100 or so different types of elements, just in different combinations. Water, for example, is made up of 1 oxygen and 2 hydrogen atoms. You guys know that water is H2O. You guys already know that. And if you pass an electric current through it, through water, you can separate that water into the two types of atoms right there. Right? You can lyse them. You can split them into 2 different types of molecules. You can split them into oxygen, and you can split them into hydrogen. So, for example, here's how we would represent this. Here's the balanced chemical equation. Here's my H2O. Here's my O2, here's my O2, and here's my H2. So we're going to split this water using electric current into oxygen and hydrogen. Now this isn't balanced. I would have to do something like that in order to balance that. And you can see that being represented in the number of diagrams that we see here. Now this is a reversible reaction. For example, in this first equation that we're seeing here, oxygen and hydrogen are considered to be the products. But most reactions are reversible. The extent to which they're reversible can vary, but most all equations and reactions are reversible. But over here, because we're going the other way, that oxygen and hydrogen, which over here were products, over here are reactants. And instead of in the presence of an electric current, in the presence of a spark, this actually ends up being combustion. In the presence of a spark, we will combust oxygen and hydrogen to form that H2O. Right? And notice that the proportions are the same. There's one O2, there's two different H2s, and there are two molecules of water here. All right? So this forward reaction, reverse reaction. These molecules are simply made up of two different elements. So chemistry in general is defined as the study of matter. Yeah, you guys already know that. And in this course, we're going to add this energy part. Not as though this is a new thing. It's simply that we didn't have the skills to study this in Gen Chem. Now, with regard to these two subjects, matter and energy, we're not necessarily going to be studying matter as it is or energy as it is. Those are actually somewhat different types of studies. We are going to focus on the changes in matter and the changes in energy. Remember, this is the Greek letter delta, which represents change. Hopefully we pick up a lot of these shorthands way to write things, because writing out the phrase change actually gets somewhat tedious after a while. So the Greek letter delta, changes between them, right? Changes between matter and matter, changes between energy and energy, and even changes between matter and energy, which would be a little bit more of a nuclear change. But here we go. So why study chemistry? This is an annoying question that I get a lot from students. And I have come to what I believe is the best possible answer. And it's not necessarily one of the things that we see in this packet here. These are the types of questions or responses that you might hear from other teachers. This helps you become a better problem solver in all areas of your life. And it truly can, if you try to apply what you know to every situation that you come across. Yeah, you can learn to solve different problems, but not everyone has that skill set. I hope you develop that skill set, most certainly. It's very, very useful and very handy. But maybe not necessarily. Are we going to be able to utilize thermodynamics in a meaningful way in our day-to-day lives? Maybe not. Okay, maybe not in a useful way, in a practical way. Safety. For example, the Roman Empire, when it was at its height, it had no idea what lead poisoning was. And so there are certain historians that attribute the downfall of that civilization to lead poisoning, or lead poisoning of specific individuals within that civilization that were pillars of the civilization. Since they had succumbed to lead poisoning, the civilization began to falter. Now, I am not entirely sure how much I agree with this particular phrase, even though this is held by some people who are much smarter than I am. However, what I will focus on is this could actually be a big deal: safety. Now, it is true, if you're ever going to buy a house that was built in the 70s or earlier, you're going to have to sign a waiver that says that you understand that lead paint may have been used in the construction of that house, of that home or that property. That's not that big a deal, because you can strip the paint and you can get rid of that paint, no problem. What I want to point out is I truly believe that there are going to be large changes in the field of nutrition within the next 20 to 30 years. I believe there's going to be very, very large changes in that. And nutrition has to do with how you're able to function on a daily basis, whether or not you're the best version of yourself or whether or not you're some a sluggard, tired, not able to focus version of yourself. Being able to fuel your body and fuel your brain so you can bring out the best in you comes down to nutrition and how you take care of your body. And I do believe that chemistry is going to play a big part in those changes. So we are going to be going through a lot of content this year. Not all of it's going to be super, super applicable to your day-to-day life, but I truly believe that the habits you form will affect the rest of your life. Your attitude towards work will affect you for the rest of your life. And here's what I believe the value in this course is, in addition to potentially getting a qualifying score on the AP exam. I truly believe that if we learn as young people to enjoy work for work's sake, to enjoy doing something and accomplishing something, that will set the stage, it will set the foundation for the rest of our life. Because anything that we figure out that we're passionate about, anything that we realize that we want to do in our life, we're going to have to do some amount of work to attain that dream. Once you figure out what that dream is, it's going to take a lot of work for you to get that. And I truly mean that. Anything that you decide is going to take a lot of work. There's nothing in this world that is worth having that isn't hard to get, right? It's because there's probably a lot of people that want it. And so if we can have this attitude towards studying, towards setting time aside in our day to do the things that we need to do, like prep for a test, read a book, do an assignment, things like that. If we can learn to do that on a day-to-day basis and learn not to resent that work, it's going to drastically change the quality of our life. And here's a simple example. If I absolutely loathe sweeping and mopping my floor, or a Swiffer is what I use. If I hate that, I'm going to avoid it like the plague. And when I do it, I'm going to be cranky. I'm going to be resentful. I'm going to not like the fact that I'm having to do that. So in my day-to-day life, if I have to clean, which is a very common thing to do in life, every time I clean, I'm going to be in a bad mood. It's going to affect how I view the people around me. If my wife tells me that I need to go Swiffer, and I hate Swiffering, I can't stand the work, I'm going to have a little bit of resentment towards her for asking me to do that. And, over 20, 30, 40, hopefully 50 years of marriage, that's going to add up. And it can actually affect the quality of your long-term, huge commitments in life. And so I hope that we can learn how to work and enjoy our work for its own sake, for the idea of accomplishing something.